Hello students, now we will discuss electronic circuit of AND gate. Now logic gates, there are three fundamental logic gates. Number one OR gate, which we have already discussed. Number two AND gate. Number three NOT gate or inverter. Now we will discuss second one, electronic circuit for AND gate. In the circuit diagram of AND gate, we use the property of PN junction that in forward bias the resistance of PN junction becomes 0, that is PN junction gets short circuited in forward bias, and in reverse bias the resistance of PN junction becomes very high, that is PN junction acts as open circuit, means no current flow through it. Suppose this is a battery of 5 volt and positive terminal connected to 2.0, which is used to give input 1 to the AND gate, and negative terminal of the battery connected to earth. Suppose this is input A and a PN junction D1 is connected so that N type of it is toward the positive terminal of battery of 5 volt, and suppose this is input B and diode D2, PN junction D2, again negative terminal of which is toward the positive terminal of battery, and P type of the diode are connected through a resistance R to the positive terminal of battery of same volt 5 volt, and negative terminal of which is connected to earth, and this is output for the AND gate Y, points across which Y is the output. Now this point is connected to earth, and these points which are connected to earth L, M, N and P, they are actually connected to each other, and point P is used to give input 0 to the input to the AND gate. Now truth table of AND gate. Suppose this is input A, this is input B and output Y. For AND gate, if A is 0, B is 0, output is also 0. If A is 0, B is 1, then output Y is also 0. Sorry, again 0, output Y, output is 0 if any of the input is 0 and A is 0, therefore output Y is also 0. Now for A is equal to 1, B equal to 0, the output Y is 0 as B is 0. If both are equal to 1, then output equal to 1. Now first case, when A is equal to 0 and B is equal to 0, that is A is equal to 0, B is equal to 0. Now we will prove the output Y is also 0. For 0 input, connect A to point P and B to point P. The N-type semiconductor of PN junction connected to low voltage 0 volt, and P-type of the PN junction is connected to positive terminal of battery at point M through the resistance R. Now if it is forward bias, that is, then the both PN junction become forward bias and current. These two PN junction are forward bias and current flow through both the PN junction and no current flow through the output. See it, the current is flowing through the PN junction and no current is flowing through the output or outer circuit. Therefore, potential between point C and D, that is potential difference between point C and D is 0. Potential difference between point C and D is 0. Therefore, output Y is equal to 0 for A is equal to 0 and B is equal to 0. So this is the first case. Now second case, when A is 0 and B is 1. Second case, when A is 0 and B is 1, for A is equal to 0, connect A to point P, and for B is equal to 1, connect B to point O. Now then the PN junction D1, this is PN junction D1, is in forward bias. The junction PN junction D2 is now reverse bias because both P-type and N-type semiconductors in the junction are at the same potential. P-type semiconductor connected to 5 volt battery positive terminal and N-type semiconductor also connected to battery of 5 volt. So potential of both the semiconductors of PN junction are at same potential and no current flow through it. And current flow through the PN junction D1 as shown. See this, current is flowing through PN junction D1. Therefore, potential difference point between point C and D is again 0. Therefore, output Y is equal to 0 for A equal to 0 and B is equal to 0. This is the second case. We have proved if A is 0, B is 0, if A is 0, B is 1, then Y is 0. Now, third case, when A is equal to 1 and B is equal to 0. So this is the third case. For A is equal to 1, connect A to point O at 5 volt battery, and for B equal to 0, connect B to point P. Then the PN junction D2, this is PN junction D2, is in forward bias as N type of it is connected to low voltage and P type of it is connected to high voltage positive terminal of the battery, and current flow through the PN junction D2 as shown. See this, the current is flowing through PN junction D2. Therefore, potential difference between point C and D is again 0 as no current is flowing from C and D. Therefore, output Y equal to 0 for A is equal to 1 and B is equal to 0. Now fourth case, when A is equal to 1 and B is equal to 1. That is both A and B is equal to 1. Now we have to prove the output Y must be 1. Then to connect, to give input 1, connect A 2.0 and B 2.0. See in the diagram. Then both the PN junction become reverse bias. Mean both the junction D1 and D2 are reverse biased and no current flow through both the PN junction, as N type of the PN junction is connected to high voltage 5 volt and P type also connected to 5 volt. So both the junctions are reverse biased and no current flow through both the PN junction and current flow through outer circuit, that is from C to D. See in the diagram, current is flowing from point C to D. Therefore, potential difference between point C and D is high. Potential difference between point C and D is high. Therefore, output become Y is equal to 1 for A is equal to 1 and B is equal to 1. So hence, if A is equal to 1 and B is equal to 1, the output Y is also equal to 1. So this is the truth table of AND gate. So this is the electronic circuit for AND gate. The number of PN junction connected is equal to the number of input given to the AND gate. If we give 3 inputs, then we have to use 3 PN junction. If there are 4 inputs, we have to use 4 PN junction. So this portion of the circuit act as a AND gate. So this is the electronic circuit for AND gate. So thank you very much.